Schon irgendwie der Hammer, oder?
It's really kind of awesome, isn't it? They look mega with the flocking. It's huge what a difference it makes. But now I'm interested what you say about the sound.
Was sagst du zum Klang?
Ja, ganz ehrlich, jetzt nicht gedacht.
Honestly, I would not have thought that. So optics, as you said, is super. And it sounds really, really awesome. But honestly, what is the whole background? I mean, it was again such a typical Olaf project. Please tell us.
Yes, exactly. The question is justified. Why does SCHNIER Electrostatic make flocked speakers? They are not for sale either. I will explain the project very briefly, but I suggest we go to the speakers. The project actually started years ago when we were looking into 3D printing. We found the 3D data for this beautiful shaped loudspeaker on the internet. Then we printed 4 half shells, glued them together and built them into the 2 speakers. Then we also found out that the sound is not bad at all.
Yes, sound was good, but the surface was not. That's why we said we flocked the whole thing and we did it in red. It looks really great. And flocking has really great properties. It feels good, looks awesome, and yes, it turned out very well in my opinion.
Exactly, the only issue was that we didn't have enough bass, because the speakers are relatively small. That's why we designed our own subwoofer housing. We couldn't find anything on the internet that we could use, so we calculated and designed our own subwoofer. Then we printed the housing in white plastic and flocked it with a white flock. That the devices then also get a proper place, we have designed the rack in the same look as the sub. We then printed this in red and also flocked it in red.
Okay, and by the way, we have also recorded all these steps on video and we can watch them right now.
All housing parts were printed on our FDM printer Ultimaker 5s from Plot. Here you can see in time-lapse how the subwoofer cabinet was printed with white Plot. We flocked the subwoofer in white and therefore also used white Plot. This saves the need to color the adhesive, but more on that later. After printing, the housing was sanded a little. This was not necessary to improve adhesion, but rather to smooth out any unevenness. For the best possible adhesion of the adhesive, the housing was cleaned and degreased. Since the geometry of the subwoofer is relatively simple, we could easily apply the adhesive with a paint roller and touch up small areas with a brush. The open time for the adhesive used is at least 30 minutes, so we were not under time pressure and could apply the adhesive very carefully. To prevent the flock from drying out and to ensure consistent quality, the flock area should be humidified. In our flock laboratory, we use an ultrasonic humidifier from Merlin, which can also be purchased from us. After that, the flocking was done in our flocking cabin with Dust-O-Mat as suction. Since we only have outer contours on the subwoofer, we were able to flock it purely electrostatically. For this, we used our easy flocker and the applicator with 120 mm diameter. With purely electrostatic flocking, the flocking is somewhat nicer, since purely electrostatic forces are used to inject the flock fibers into the adhesive. In electrostatic pneumatic flocking, kinetic forces still act on the flock due to the airflow, and the flock does not stand quite as upright as in purely electrostatic flocking. However, purely electrostatic flocking is not suitable for flocking three-dimensional parts with undercuts and recesses, such as speaker housings. After the glue has dried, the excess flock is blown off, and we think that the result is impressive. The device rack was flock tread and therefore printed in red pla right away. when the housings for the speakers were printed. The idea of flocking was not yet there, otherwise we would have printed them with red ply as well. We had therefore carried out tests to see how the red flock works on a black background. For this purpose, we had coated a sample part with non-colored adhesive and primed a sample part in advance with red colored adhesive, and then also coated it with non-colored adhesive. Both parts were then flocked with red flock with 0.5 mm length in 3.3D text. As seen in this overview, there is a clear difference between the two sample parts. On the sample part without red primer, the black background shines through and the actually very bright red flock looks more like wine red or even a bit dirty. The best result is obviously on the equipment track, which has already been printed in red. However, the sample part, which was primed with red glue in advance, also turned out very nice, and so we decided to go this way. For this purpose, we coated the sanded and cleaned speaker cabinets with red colored adhesive. A spray gun was used for application. The speaker housings have a much more unusual surface with several depressions, so purely electrostatic flocking, as used for the subwoofer, was not an option. Therefore, we used our electrostatic pneumatic Air Flocker Pro. With the Air Flocker Pro, the flock fibers are dosed via a dosing brush through a sieve into an airstream. The airstream transports the flock fibers through a hose to the electrode in the handle. There they are charged with high voltage and applied to the workpiece. The speaker housings were then dried until the adhesive was completely cured. Finally, as usual, the excess flock was removed and the speakers were mounted.
For me, this was actually an absolute dream project, because we addressed three senses here. First, of course, the feel. Flock simply feels good. Then the sound, but in this case the flock can do relatively little for that. But of course also the look. Here on this project you can really see what a difference flocking makes and how brilliant it actually looks.
I think you already know our motto. We like to flock it. And if you liked it or want more information, please write it in the comments below or go to our homepage. You can also check out our other videos. So take care and bye bye.